Okay, so in this video, I want to show you, talk to the neuroanatomical connections that are what scientists use to study repetitive behaviors in autism, either in animal models or in human studies for MRI or fMRI studies. So I draw a picture, and we've got these, you can think of these as habit pathways, and you can think of it as a motor habit pathway, a thought habit pathway, an emotion habit pathway, and spoken language habit pathway. There may be others that they've found, but these are all part of these connections that I'm talking to. They're called frontal striatal connections because they go from the frontal part of the cerebral cortex to the to a part of the basal ganglia called the striatum. So they call it the frontal striatal loops, but I talk about them as habit pathways. So these are the pathways that scientists study in terms of looking at repetitive behaviors in autism. So if you think, it's easiest to think about from a motor perspective, that once we get in a very, patterned way with something, it's hard to break out of it. And so in autism, we might see flapping of hands, and we talked about how those there's short connections that are accessed every time you move. And so because kids with autism have a hard time breaking out of things, but also have a hard time with learning, with motor learning, especially in a visual, what they call a visual motor kind of way. So they are more likely, we all get ingrained in patterns, which is fine if it's something like tying your shoes, because you want to be able to do that without thinking about it. But if it's like spoken language and trying to teach that, you might see a lot of repetition, right? With echolalia, or always saying the one word or a certain phrase constantly. And so that repetitive behavior you can think of as that these pathways are more ingrained in kids with autism, but it's harder for them to break out of them because, well, there's evidence that the short connections, like between these paths and the ones that go from the front part of the brain to the back part of the brain, those are kind of broken up, and so there's less ability to break out of those patterns. So think about, like, one of the examples I use is after you've done a pin, it's an automatic, but then when you have to when you switched it, you have to think about it. And so that's one thing for kids who have iPads that they might use to communicate. They are able to learn their code, and so some people might say, well, then they don't have a motor problem. But they do. It's a visual motor problem, and it's a cognitive motor problem. So for all of us, like when the date changes at the beginning of the year, you're used to writing, when it turns 2021, 2022, we'll have just gotten used to writing the date as 2021. And so it'll take us a good month until it becomes habitual. But we have to think about it. We have to stop and think about it. That part of stopping and thinking about it is not working well in our kiddos' brains. So we talked about switching between patterns. Then one thing you can try with your kiddo is that just to kind of give you a feel for it, or if you're in a therapy session, try having a kiddo hit their knee to a drum or their foot to a drum. So it'd be mixing it up in terms of what body part they're supposed to use, and they're oftentimes used to hitting a drum this way, and so that pattern is hard to break up. And so if you switch it on them, and you'll also see this with the whiteboard when they're making choices. If you put a whiteboard in front of some of these kids, they'll just automatically go for Whereas they have to sit down, slow down, think about what they're doing, and then make their choice.